A flying aircraft disturbs the local atmosphere through which it flies, creating a turbulent vortex at each wingtip known as a wake vortex. These vortices are essentially invisible horizontal tornadoes and are a grave threat to smaller aircraft, especially during landing and takeoff. Accidents related to wake turbulence have resulted in both loss of life and aircraft destruction in the United States and globally. Currently, no cockpit instrumentation exists that tracks wake turbulence. We present a prototype of a novel flight-tested instrument that dynamically tracks wake vortices and presents this information to a pilot in real time. We have created an augmented altimeter strip that conveys potential wake turbulence hazards to a pilot in real time. Telemetry data between all nearby aircraft is exchanged wirelessly using the FAA's next-gen Automatic Dependent Surveillance Broadcast Protocol. This protocol is currently being adopted worldwide and will become mandatory for all major airports by 2020. Using position and orientation of nearby aircraft, we dynamically construct conservative surfaces bounding wake hazards. The pilot is informed of these potential hazards via a simple addition to the traditional altimeter, minimizing pilot training and requiring no additional cockpit space. This video segment shows the same flight identically time-aligned at twice normal speed from 4 different viewpoints. This test flight was performed at Ohio University's Snyder Field. The top left shows a high-level bird's-eye view of the leading and trailing aircraft, whose flight paths are blue and yellow respectively. The top right shows an over-the-shoulder view of the trailing aircraft. The bottom shows 2 views of the primary flight display of the trailing aircraft. The bottom left shows the blue and red ribbon segments of the leading aircraft, while the bottom right shows what the pilot would typically see using a standard primary flight display enhanced with our augmented altimeter. Our augmented altimeter is shown on the side of the primary flight display to the right of the green pitch ladder and compass in the bottom 2 windows. Wake turbulence is tracked and computed as shown in the upper left. A tracking volume in the shape of a semi-cylinder is intersected against the blue ribbon, resulting in the red segment. The maximal altitude of this red segment is used to populate the red wake strip bar of the augmented altimeter, as it defines a conservative boundary above which is free from wake turbulence. If the pilot in the trailing aircraft remains above this red marker, wake turbulence will be safely avoided, as it only moves laterally or downward except in extreme weather conditions. When on approach for landing, this instrument will aid the pilot in what the FAA calls fly high, land long, the canonical method for safely landing near wake turbulence. The geometry of the intersection volume can be dynamically altered based on the current maneuver. For example, a cone could be used when an aircraft is on a final approach to an airport with multiple runways. While cruising or navigating around an airport, a semi or full cylinder or sphere could be used to track wake turbulence and convey it to the pilot. This augmented altimeter will save lives, reduce aircraft destruction, increase safety of general aviation, remove burden from air traffic controllers, create jobs for device production, and integrate well with the FAA's next-gen vision. As the skies become more populated, the risk of wake turbulence increases. Concordantly, demand for our augmented altimeter will increase as well. Avoiding hazardous wake turbulence will not only save lives, it will also reduce wake-related aircraft damage and destruction, which increases overall aviation safety. Furthermore, air traffic controllers will be alleviated from the task of informing nearby aircraft about potential wake turbulence. Producing this device and selling to avionics manufacturers will create much-needed jobs in our area of Appalachian, Ohio. If widely adopted, our device may eventually become mandated by the FAA, and even more job creation would result.